Okay, so this is the beginning of English medium class and this is your first day. So as some of you may have already seen my introduction video in the Sinhala medium, so I have told there are a lot of things that you have to know regarding A levels, what you should do there, what you should do in your A levels, and how should you prepare mentally and also physically, how you would prepare your surrounding and your mental state and everything. I have spoken a lot there. So if you don't watch that YouTube video, it's in the group, the WhatsApp group. So it's in the WhatsApp group. So you can first watch that video, and then second you can watch this one. Okay. So I am not going to repeat the same thing in this video. So if any of the student have any difficulty in understanding the language Sinhala, so you can directly WhatsApp me and tell, I cannot understand any word in Sinhala. So if so, I will do that introductory part again in English medium also. So in here I talk in English, and also at sometimes I also use some Sinhala words, because I think all of you can understand Sinhala. So but I'm trying to speak in English every word, but sometimes I just use some Sinhala words also, right? Okay. So I have sent you already the syllabus part, PDF syllabus. So in syllabus, just see that there are 14 units. Okay, there are 14 units. Some of the units, the main topic of some of the units may be familiar to you. For example, the first unit, so the unit we are starting today, that is the atomic structure. So in atomic structure unit, you have to study about the atom. I think you have already know some things, some details about the atom. I think in your O levels you have studied the atom, Dalton, I think the electron, protons, then the isotopes, then the mass number, atomic number, then the ionization energy, electronegativity, etc. So all these things comes under the unit 1 atomic structure. This is not a big lesson, but it takes some time because it is just the foundation of your course. Okay, so this is like a journey. So this is the foundation. The first unit is the foundation. So in building a house, the most important thing is not the walls, not the roof. It is the foundation that you build, right? The foundation is very, very important. The base or the foundation is the thing that will make you much, much stronger through this journey. Okay, so the first lesson is also very easy. This is very easy lesson. Okay, the atomic structure lesson is very easy. It's not a difficult one. So no one can face any trouble in understanding this unit. So this is easily understandable. Okay, so before starting that, I will tell you some rough idea. You have to get some rough idea about the other units also. So the unit 2 is about structure and bonding. So there you have studied about in O levels the covalent bonds, the ionic bonds, and etc. I think you have drawn Lewis structures also, I think dot and cross structures. So all these things comes under structure and bonding part unit. Then the third unit is the chemical calculation. So in chemical calculation unit, you have to study about the calculation part. In your O levels, you have to calculate number of moles, then the concentration, everything. Okay. So then that is the calculation part. Then the unit 4 is the physical state. They are the gaseous state of matter. So in that lesson you have to study about gases. There is a detailed description about the properties of gases and how gases behave, so on. Okay, so it's basically on about gases. Then the unit 5 is the energetics. It's like the thermochemistry. That means you are relating the energy change, heat energy change during a reaction. So you already know the equation Q equals mc delta T. So that is related with that unit. Then the unit 6 is about SPD block elements. So in your O levels you have studied about some elements, details about some elements like sulfur, nitrogen and etc. So those things, inorganic elements or the inorganic part comes with those lesson. Okay. Then the unit 7, 8, 9, 10, those units are based on organic chemistry. So what you know already about the organic chemistry is the hydrocarbon unit in your O levels. So we have to not only the hydrocarbons, there are vast diverse varieties of organic compounds in the world. So we have to study them in separate groups like hydrocarbons and then the oxygen containing compounds, nitrogen containing compounds, and like that way. Okay. Then the unit 11 is the chemical kinetics. So the unit chemical kinetics is about the kinetics, that means it's about the rate of a reaction. That means the speed of a reaction, how a reaction occurs, what is the speed of a reaction. So I think in your O levels there is a unit for the speed of a reaction. So it's state basically about a reaction rate or the speed. Okay. Then the unit 12, don't think a single idea about that, don't think about that, because that lesson is completely new to you. Lesson is the equilibrium, so don't think about that. And then the unit 13 is electrochemistry, but the electrochemistry word is much more familiar for you because you have already studied about electrochemistry in your O levels. You know electrolysis, you know dry cell and the cell, chemical cell. Okay, those things. So that is simple. Most of the parts in that lesson is already you know from your O levels. Okay. Then the last lesson is the industrial chemistry, okay, and the environmental pollution. So this lesson is very important because once you study chemistry subject, then if you study it in advanced level, and after that if you study it in advanced in universities, you have to study industrial chemistry parts also. So if you are interested in industrial parts, that means in industries, you can join any industry in the field and you can work there as a permanent job. So this industrial part is really a practical one. It is vastly distributed all over the world in small and large scales. Okay, so then the environmental pollution is a familiar thing. You know about the global warming, acid rains and etc. So those are really familiar to you. Okay, so this is basically a rough idea about the all 14 units in this your A level syllabus. You have to study these things within the period of 2.5 years. Okay, so this is actually, as I told in that introductory video, A level is actually not so hard. Okay, the problem is the workload. The workload is so much there. There's a huge workload. So therefore, what is important in here is you must concentrate on your work from your first day. You have to do self studies from the beginning, not only just a start. You have to continue the form, and you have to develop the form, and you have to prepare in a harder way. You have to prepare it in a precise, in a correct, in a well managed or well organized manner to upgrade your performance. Okay, that's very important. So as you know already, I am Ravindra Dharmapriya, chemistry specialist. I have a special degree in chemistry from University of Peradeniya, and also worked in the department of chemistry, and now I am conducting chemistry classes. Okay, so you meet me, so it's like you are getting the subject very clearly, because the reason I am telling this is I have studied 4 years this subject with a specialized degree and with the class. So there is a lot of knowledge, so I can share with you. This is very important for your future journey. Okay, so it's very important for you to choose a teacher who is really specialized in that area. Okay, so he or she should study that subject in university in details, so you can get much more knowledge and much more correct knowledge. Okay, you can get much more accurate subject from a teacher like that was teacher like me. Okay, so even for physics and combined maths or biology, please select a teacher who is really pioneer in that area, in that subject in a university. Okay, so that's just the introductory. So I think just we can begin now. Okay, that's enough for the introductory part. Okay, now take the note, take a book. So this is really an introductory part. I'm not going to teach you a lot now in the first video. So as I said, please watch the first my introductory video in Sinhala medium. So I think all of you can understand Sinhala. As I said earlier, if anyone has a difficulty, please tell me. Okay. Then let's begin this. Okay. Let's start. Now I'll write a word in the blackboard. Okay, see this one. This word is really familiar for you and not a new word. Let's see. Actually this doesn't matter you. Okay, the word is matter. Matter. So what do you think about this word matter? Something might come into your mind. Okay, what is matter? You have the question, what is matter? So when considering about a matter, there are two basic things you have to know. So for anything to be a matter, there should be two things. Okay, the matter should have, the one first thing is, this should have a mass. So anything that have a mass is matter, and the next one is it should occupy space. Occupies space. Okay, so ourselves, when we see here, you and me, all of us, we have a definite mass. We have a mass, and we occupies a certain volume in air. So it is equal to the volume of my body. Okay, so my body volume is the volume that occupies in space. So any object having a mass, anything having a mass and occupies certain area in space is called as a matter. Now write the note. Okay, write down. So in writing the note, please maintain a very clear note. Okay, so if you write it in a clear way, it is very easy for you to study. Okay, it's very easy. Right, so if you read the note, it is very easy to remember also. So write it clearly. Don't write it in long sentences. Just write everything in a point form. Okay, you can write by keeping some spaces between your rules, and then please write it very precise, very clear way. Okay, right. So use the point form. You can put stars and write it in point form. Okay. Now write the topic matter. First of all, write the main topic. Okay, unit 1, atomic structure. You can write this in any color. Atomic structure. This is the first unit. You can bold it or you can do anything. Okay. කැටය මෝන එකක් දාගන්න ප්‍රශ්නයක් නැහැ. හරි okay. ඇම්බැක් කරවඩා කැටෙන් දෙම ප්‍රශ්නයක් නැහැ. හරි. Atomic structure. Atomic structure. Okay, right. Now write the subtopic matter. Matter. Let's see what is matter. Right. Write the note. Matter is anything. Matter is anything. Matter is anything that has a mass. Matter is anything that has a mass. That has a mass and occupies space. And occupies space. Clear? Matter is anything that has a mass and occupies space. That's clear. Occupies space. Okay. The matter, as you know, matter is consist with two fundamental physical states. So the matter has three physical states basically. The three states are solids, solid state, liquid state and the gaseous state. So everything around us, every matter around us is either in a solid state or a liquid state or a gaseous state. Okay. But there is a fourth state which is called as the plasma state, but it's not in our syllabus, it's out of syllabus, so no need to know in detail. Okay. So the three basic physical states of matter are solid, liquids and gases. Write down. Matter consists of three physical states. Matter consists of three physical states. Number one, solid state. Number two, liquid state. Number three, gaseous state. So basically solids, liquids and gases. Okay. Gaseous state. So write that. Okay. So why we need to know about these things? Basically the thing is this. So these matter in any state like solid or liquid or in a gaseous state, these matter are used for, this is very important. So these matter are used for, so they are used for production of materials. Okay. So the matter in either solid state or liquid state or gaseous state, we use them. How do we use? We use them to produce materials. So these materials are important for our day-to-day life, for human beings, basically. Okay, basically for human beings. Example: soap, sabang kella, soap. So for the production of soap, we need to use the liquid matter. Example: coconut oil. We use coconut oil to produce soaps. So the coconut oil is in the liquid state. We use the properties of that liquid. We use the properties of this matter and the chemical reactions between them to produce these materials. Okay. So that is very important for our day-to-day life. Write down note. Write down. In chemistry, we study properties of matter. So we have to study properties of matter. What are the properties of a solid, gases and liquids? Okay, that's very important. Properties of matter and reactions of matter. That involves production of materials that are used for the benefit of human beings. Okay, that's very easy. තේරෙනවද? ඒතර සබන් කැටයක් ගත්තොත් සබන් කැටය හදන්න ද්‍රව්‍ය ඕනේ. matter. We need matter. So matter consists of either solid, liquid or gases. We use oils, coconut oil for production of soap, so it's a liquid matter. We use other raw materials also, so we use those matter and the properties of those matter for the production of soap, which is important for our day-to-day life. That's simple. Okay. So the basic thing in chemistry is we need to produce things. We have to synthesize, produce materials, okay, which are important for our human beings and our day-to-day life and for overall human beings. Okay. Right. Now we have to consider about the fundamental properties of a solid, fundamental properties of a liquid, and fundamental properties of a gas. Okay. So just listen this. I will explain to you not today, in the second day, in the second day of your class, about the A-level chemistry paper, about the MCQ paper, about the structured paper, and about the essay paper, and the marks allocated for each paper and how you should prepare for them. And I will tell you in a detailed manner everything about the paper. Okay. So but in the first video I am not going to tell anything about the paper, so I am going to just concentration on some of the lesson parts in the lesson. So I will continue the lesson until end of this video, okay, until the end of this class. So after that, in the next session, I will tell you in a detailed manner about the paper and also the lesson. Okay, I will collectively do that. Okay, so just wait for that moment, and I will not going to tell you about the paper today. Okay, write down now fundamental properties of a solid. Write down fundamental properties of a solid. Fundamental properties of a solid. Fundamental properties of a solid. So for a solid, if we look at this board or myself, so I am a solid, this board is a solid. So there are two basic properties that we see. First thing is myself and also this board, it has a fixed shape. The shape is fixed, definite. Okay, shape is definite shape. It has a definite shape, definite or fixed. So this is like grade 8 science. Okay, very simple. So any solid has a definite shape. It can be either rectangular, it can be either triangular, circular, whatever the shape. It has a definite shape. And also this blackboard occupies a certain volume in space. Okay. So this blackboard has a certain volume. You can get the volume of a rectangle. No? So this has a certain fixed definite volume. Right. It has a definite shape and a definite volume. Write down the number 1, first one, number 1. Solids have a definite shape. First property, solids have a definite shape. Solids have a definite shape. Okay, definite shape. Number 2, have a definite volume. Have a definite volume. Have a definite shape, have a definite volume. So definite or a fixed, same. Okay, same idea. Definite shape, then a definite volume. Okay, right. Then let's write down fundamental properties of a liquid. Liquid එක බලමු දැන් අපි. Fundamental properties of a liquid. Okay. If you have a water bottle near to you, just take it and see. If you put water into a bottle, for example, for your water bottle, it takes the shape of your bottle. If you put the same water into a Marmite bottle, Marmite bottle, it has that Marmite bottle shape. Marmite bottle shape එක තියෙනවා. It has. So if you put that into a flat bottle, flat shaped bottle, it takes the shape of the container or the shape of the bottle. If you put into another shape, another different kind of a shape, bottle with a different kind of shape, so if you put the same liquid there, same water, it take up that volume, take up that shape. Okay, so liquid doesn't have a definite shape, it takes the shape of the container or the bottle. Write down number 1, no definite shape, no definite shape, no definite shape, no definite shape. Right there. Shape of the liquid, shape of the liquid is the shape of the container. Shape of the liquid is the shape of the container. Shape of the liquid is the shape of the container. Alright, okay. Volume එක ගැන මොකද? What do you think about the volume? If you, for example, if you take a soft drink bottle, Coca-Cola or Sprite or whatever, there is a definite volume in that label. Either it can be a 500 milliliters Coca-Cola bottle, 1 liter Coca-Cola bottle, or a 2 liter Coca-Cola bottle. So there is a definite volume. So in that definite volume, it has in that bottle there is a definite volume of Coca-Cola. 500 milliliters, if it is 500 milliliters, it is 500 milliliter, definite fixed value. In a 1 liter bottle, it has a definite volume, okay, definite volume of 1 liter. In a 2 liter bottle, it has the definite volume of 2 liters. So write down the number 2, what is that? Right, have a definite volume. So the liquids have definite volume, have a definite volume. Have a definite volume. Okay, so have a definite volume. Write down, now let's see the fundamental properties of a gas. Write down fundamental properties of a gas. Right, fundamental properties of a gas. Now it's the new year season now. Okay, so all of you now prepare for the new year. So the relatives comes into a house, you go to your relative places, and lot of other activities, or right, house service, whatever, so on, blah 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 blah, everything is there. So as this is just the beginning of your A-level life, don't just concentrate here, to just enjoy this අවුරුදු. This අවුරුද්ද, මේ අවුරුද්ද හොඳට enjoy කරන්න. You go to your relative places, you go to your, because the next year it is not like this, lot of work to do in the next year. So within this year, this new year celebration, you have to take it in advance. Okay, you have to take it in full. හැම ගෙදරකම යන්න නෑ, ගෙදරක යන්න, හැම එකටම යන්න, ඊළඟට අවුරුදු උත්සවයට යන්න, කිසි ප්‍රශ්නයක් නෑ. It's no problem, because just a fresh start for you, nothing matters. Don't think it's serious, it's just start, but just for even do some studies also, okay, but there is nothing to study in these days, because just the beginning. No, so it's just the beginning, but after 1 year time, you don't have the freedom like now. You will not get that freedom, so you have to study hard at that period. So enjoy your last but peaceful new year celebration this time. Okay, right, now write fundamental properties of a gas. Fundamental properties of a gas. Fundamental properties of a gas. Number 1, if you so the gases, so I can touch the gas in here, yeah, okay. Once I touch here, I cannot see any definite shape. So I cannot say this air is rectangular, this air is circular, this air is triangular. No shape, no definite shape. Also I cannot say a definite volume for the air. So the air in this room, I cannot say for the air in this room, I cannot say a definite volume, how much of volume is there here, I can't say. So for a gas there is no definite shape and there is no definite volume also. Write down. Number 1, no definite shape. No definite shape. Number 2, no definite volume. No definite volume. Clear? Okay, it's just the basic things. These things, all of you know these things from your grade 7 or grade 8 or whatever. Okay, so that's simple thing. Just focus on the basic things here, right? Then when we talk about the history of science, there are a lot of eras. There are a lot of philosophers that put forward ideas. Okay, so the thing is, scientists and the philosophers had a doubt about the matter. So when we see the blackboard, we will normally not think about what is this blackboard made of, what is inside this blackboard, what are the things that made this blackboard like this. So but in those era they think about matter in the way what matter made up of. Matter එක හැදලා තියෙන්නේ මොනවෙන්ද, right? What is inside the matter, right? Like that. So they had a lot of questions like that. So several scientists and philosophers put forward different ideas there. Okay, so there were Aristotle, but it's not important. Okay, Aristotle. Then there was one called Democritus, but his idea is good. Democritus says that this matter is made up of indivisible means cannot be divided further particles, like things named as atoms. Okay, that's something like that. But the precise identification for an atom is put forward by a scientist known as John Dalton. This is the scientist that precisely explained the word atom. Earlier it was the Democritus who put forward this word, but it's not important because Democritus' explanation is not enough. Okay, so the precise explanation for the atom is put forwarded by John Dalton. So what is this atom? Dalton said every matter around us is made up of atom. If we say this is the matter, so this thing is matter. So this is the matter. So matter is made up of particles. They are separatable, separate particles, and each particle is known as atom. This is the smallest particle. So the smallest particle that the matter is made up of is known as the atom. That's the smallest. Smallest means we cannot divide this further. Okay, Dalton says this particle, smallest particle is indivisible. Divide කරන්න බෑ තව දුරටත්. ඒ කියන්නේ ඒක තමයි චූටිම එක. ඒක ඇතුළට තව දුරටත් යන්න බෑ. You cannot go inside that particle. So that was the Dalton's idea. Okay, then he put forward Dalton's atomic theory. Okay, so now write down the topic: Dalton's atomic theory. Dalton's atomic theory. Dalton's atomic theory. Write down. Dalton's atomic theory. Okay. Now, Dalton's atomic theory. Dalton's atomic theory. Okay, write this. Dalton put forward the atomic theory that consists of four postulates that consist of four postulates. Postulates කියන්නේ මොනවද? What are postulates? In Sinhala we said that උපකල්පන. සාමාන්‍ය විහාරය ගත්තොත් මනස්ගාත. That means they are not real things. They are the things that we think. So sometimes that when we are in some places we think this may be like due to this thing like this. No, so they are just thinking things. They are not real things. So the postulates. There are four postulates about atom. Okay. So the number one is this: atoms are extremely small, very small. Okay, very small, invisible. So we cannot see into our naked eye. Invisible, very small, and indivisible. We cannot divide it. Indivisible. So this is the smallest particle. It cannot be further divided. Okay, indivisible. Like building blocks of matter. So they are called as atoms. Right. Write down the number one. Matter is made up of extremely small, comma, invisible. We cannot see it into our naked eyes. No, invisible, and indivisible. That means we cannot further divide that part, atom. Indivisible. Building blocks of matter called atoms. Okay. Okay, this is the first postulate. So the Dalton said that atom is the smallest building block of matter, which is invisible, very small, and indivisible. Okay, right. Then number two. Then the Dalton said that all the atoms of the same element are identical in size and also the mass, and it is different from the other elements. For example, let's see carbon atom, the isotope carbon 612. Let's see like this. So there are isotopes, no, carbon 612, like that isotopes. But in the period of Dalton, we don't know about in those periods the isotopes are not yet discovered. Okay. So Dalton said carbon atom in any place, that means let's see carbon atom in Sri Lanka, anywhere, carbon atoms in Australia, America. Okay, so if the same element, all the atoms of the same element are identical, they are same. That was the Dalton's postulate, right? All the atoms of the same element are identical. Okay, identical, but they are different from other elements. That means the carbon is different from iron, no, carbon is different from sodium, carbon is different from oxygen. That's okay, because the atomic number is changed. But even Dalton says the mass is also same. Okay, mass and the sizes of atoms are same. Okay, but this postulate, as you know from your O-level knowledge, it is false. Why? Because there are isotopes of four elements. There are isotopes. Therefore, in isotopes the masses are not same. But Dalton says that all the atoms of the same elements are identical. Write down the number two. the second postulate, number 2, all atoms of a same element, all atoms of a same element are identical in mass and size, identical in mass and size, but the atoms of one element, are different from the atoms of all other elements, Okay, this is the second postulate, but as we know it is a false statement, false postulate, because due to the presence of isotopes the masses are different, even though for the same element there are different masses for atoms, right? Okay, but in that era isotopes are not discovered, that's the problem. Okay, now the number 3, write down number 3, third one. What is that? So I think all of you have seen the Harry Potter series, which was a very famous and vastly famous. Okay, all around the world. I think there are maybe a very little children who doesn't watch this one, who didn't watch this one. I think all of the in our childhood this was the favorite, one of the favorite movie. Okay, in that era. In Harry Potter, I think you have seen there are a lot of spells. There are spells like that. Let's see, Wingardium Leviosa. Like that. Maybe it's very incorrect. Okay, I'm as I can remember, Wingardium Leviosa, whatever like that. So when Harry does that thing, so some creature created, something created. Okay, so the matter is created. Okay, so like that, and when we say the expectro patronum, whatever the spell that is, something is lost, destroyed, like that. So the Dalton says that the matter cannot be created. Dalton says we cannot create matter, and also we cannot destroy matter in a chemical reaction, during a chemical reaction. So in a reaction, Dalton says matter cannot be created. ඒ කියන්නේ reaction එකක් වෙනකොට කලින් තිබ්බේ නැති, initially තිබ්බේ නැති matter එකක් finally product එකක් හැටියට create කරන්න බෑ කියන එක. Also matter cannot be destroyed. Initially තියෙන matter එකක් reaction එකෙන් පස්සේ destroy කරන්න නැත්නම් ඒක නැති කරන්නත් බෑ කියන එක. But you know this is a false thing. Nuclear reactions, let's say nuclear reactions. For nuclear reaction matter cannot be destroyed. We know that one. So but in that period nuclear reactions are not found. So the Dalton's idea was, right, matter cannot be created neither destroyed during a chemical reaction. Write down the third one. So atoms are neither created nor destroyed, neither created nor destroyed in chemical reactions. Okay, this was the third one. Now the final one, fourth one. Let's see. The Dalton said this: when we form the compounds, for example H2O, simplest compound, H2O, water. So Dalton said when forming compounds by combining different type of elements, these elements were combined in a simple whole number ratio or simple numerical ratio. So let's see H2O, simple example. In here there are two types of atoms, hydrogen and the oxygen. Two hydrogen atoms combine with one hydrogen atom, therefore the ratio between hydrogen and oxygen is 2:1. This is a very simple ratio, very small ratio, and also a whole number. There is no fraction. There is no like 2.5 to 1, 4.5 to 1 like that. There are no, right, in this postulate. He said that only whole number, whole number and the numerical ratios are also, only numerical ratios are combined together, right. Write down. Number 4, compounds are formed by the combination of two or more atoms, of different elements, in simple numerical ratio, right. Write down examples. H2O. Hydrogen to oxygen ratio is 2:1. Write down this. The next example is carbon dioxide. Here carbon to oxygen ratio is 1:2. Very simple. If we take some other, like ammonia, NH3, nitrogen to hydrogen ratio 1:3. Write down those examples. So there are a lot of examples for that. Okay, write down those 3 examples. Clear? Okay. Now, these are the 4 postulates of Dalton's atomic theory. Very simple. Matter is made up of extremely small, invisible, indivisible building block of matter called as atom. Okay, the first one. Second one. Okay, that is the first one. Right. So, what is the second one? Second one is the all atoms of the same element are identical, but they are different from all other elements. Third one, matter atoms cannot be neither created nor destroyed in a chemical reaction. Number 4, when forming compounds, elements of different elements combine in a simple numerical ratio. Okay, that's simple. Now let's see the next topic. Write down this topic, just a small one. Golf ball. Golf ball atomic model. Golf ball atomic model. Golf ball atomic model. Write down topic. You all know the golf ball, no? The sport golf. So that is a white color ball, a rigid ball like this. White color ball. Okay. So this model was put forward by John Dalton. he says that the atom is similar to a golf ball. Okay, this is like an atom. This is like an atom. So it's like that. It is same as a golf ball where the mass is distributed all over the sphere. So this is like a spherical one sphere, but the mass is distributed all over this. Okay, so mass of the atom is distributed all over this sphere or the golf ball, like that way. Atom also like that, similar to a golf ball where the mass of the atom is distributed all over that sphere. Okay, golf ball එකත් සම්පූර්ණ එක solid මේ sphere එකක් නේ තියෙන්නේ. ඒ වගේ solid sphere එකක් mass එක all over can almost in all of the whole object has the mass. Okay, write down. Put forward by John Dalton. First point, put forward by John Dalton. Put forward by John Dalton. Next point, it is same as a golf ball. It is same as a golf ball. It is same as a golf ball where it is same as a golf ball where the mass is distributed all over the sphere. Mass is distributed all over the sphere. Sphere එකක් වගේනේ බෝලේ. So එතකොට බෝලේ mass එකත් ඒකේ සම්පූර්ණ එකේ mass එක තියෙනවා distribute වෙලා. ඒ වගේ atom එකේ mass එකක් තියෙනවා. The atom mass of the atom also distributed like that way. Okay, distributed all over the sphere. Right. Draw this golf ball එකක් වගේ අඳින්න. Draw like a golf ball and mark it as the atom. Okay, mark it as atom. Write down the next topic. Electrical nature of matter. Electrical nature of matter. So this topic shows that matter has some sort of electrical properties, electrical nature. This was found in early decades, even before the Dalton's atomic theory. So scientists found out that there is a relationship between the matter and the electricity. So the matter possesses some electrical nature or some electrical properties. Write down. Even before the Dalton's atomic theory, scientists have carried out experiments which shows the electrical nature of matter. That means there are some evidences that will prove that whether there is a proofs for the relationship between the electricity and the matter. Write down. That is there are evidences for the existence of a relationship between matter and electricity. Okay. Now let's see what are the evidences that shows a relationship between matter and the electricity, right? Write down the subtopic below. Evidences for the electrical nature of matter. Evidences for the electrical nature of matter. Evidences for the electrical nature of matter. Okay. Now let's see. Number 1, first evidence. Number 1, what is this? Okay, right. First, write down the evidence. Production of static electricity. Production of static electricity. Production of static electricity through friction. Through friction. Production of static electricity through friction. Friction means the rubbing. So when we rub two objects together, we can call it as a friction. Okay, it's like a rubbing. Okay, so what is this static electricity? Let's see. What is this static? So the electricity itself has two components, as static electricity and the dynamic electricity or the current. Dynamic electricity, which is known as the current. It's a current. Static means the electricity is not moving. Electricity is not moving. Usually in our current supplies, the current is moving from one place to another, no? So it's like a dynamic one. Dynamic, it's moving. But in static electricity, the electricity stays at one position, at a certain fixed position, okay, or area. It doesn't move here and there. So that's called the static electricity. So this is caused due to friction, okay, friction. So in your childhood, you may have done this. So you mopped your hair with a comb vigorously, and once you close that comb closer to your hairs, skin hairs there, so they get erected. Or when you close them to some pieces of paper, these pieces of paper attract towards the comb. So this is due to the static electricity created on the comb due to the friction. Okay, when you mop or rub the comb with your hair, so there is a static electricity generated inside. Okay, so this is a very simple example for the static electricity generated due to friction. Okay, so there are two basic examples for this rather than the comb example. So one example is, there is a material known as ebonite. Ebonite. So you know that there are a lot of materials in the world, like rubber, plastic, glass, like that. Ebonite is also a material. So there is a ebonite rod and a silk cloth එකක් තියෙනවා, and also a ebonite rod. So when we rub the silk cloth, okay, with this ebonite rod, and we place the ebonite rod very closer to some pieces of paper, those pieces of paper get attracted towards the ebonite rod. That is due to the static electricity created on ebonite rod and the piece of paper due to, so in ebonite rod, the static electricity generated due to the rubbing of ebonite rod with silk cloth. Okay, write down examples. An ebonite rod rubbed with a silk cloth attracts small pieces of paper attracts small pieces of paper, attracts small pieces of paper when brought near it, when brought near it, when brought near it. Now the second example, write the second one. A hair combed, the comb case, right? A hair combed, a hair combed, a hair combed, mopped, 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 vigorously on hair, mopped, vigorously on hair, vigorously on hair, has the ability to attract, has the ability to attract small pieces of paper, has the ability to attract small pieces of paper, small pieces of paper. Okay, the next example, similar to ebonite, there is also another material known as amber, A-M-B-E-R, amber rod, hurry, amber rod, amber rod. When we rubbed amber rod with a woolen cloth, amber rod gets static electricity, and when we brought this near to a piece of paper, okay, they get attracted towards the amber rod also. Write down the third one, third example. An amber rod, an amber rod, when rubbed on woolen cloth, when rubbed on woolen cloth, woolen cloth, when rubbed on woolen cloth, also attracts small pieces of paper, also attracts small pieces of paper, small pieces of paper when brought near it, when brought near it. Okay, so in these two experiments, okay, due to this friction or the rubbing, there are two types of charges generated in these materials. There are two types of charges generated on these materials. One charge is known as positive electricity or the positive charge, other one is known as the negative charge. So positive and negative, there are two types of electrical charges generated. So these charges are important, they are the cause for the static electricity, right? Write down next point, not example, write the next point. The electrical charges created, the electrical charges created on these materials, the electrical charges created on these materials, the electrical charges created on these materials in these experiments, in these experiments show that there are two kinds of electricity. There are two kinds of electricity. Two kinds of electricity. They are known as positive charge and negative charge. They are known as positive charge and negative charge. Positive charge and negative charge. Okay, this is the first evidence for the electrical nature of matter, which is what? Static electricity through friction. Okay, now the second evidence, number 2, this is familiar to you, you have already learned this in your O levels. Write down the second evidence, electrolysis. Electrolysis. Write down the second evidence, electrolysis. So that is the second evidence, electrolysis. Electrolysis. Right. You know from your O levels what is the meaning of electrolysis. You know it already. Okay. Electro means the current, lysis means the breakdown. So there are two parts of this word. One is electro, that means the electricity. Electricity. Lysis means the breakdown. What we do here is we break down larger complex molecules. Larger complex molecules or species into simple forms. So the larger structures, larger complex structures are broken to simple species forms, like maybe like ions or atoms or whatever. Okay, simple forms by supplying external electricity. Okay, we can supply the external electricity through a DC current, that means through battery. So you can break down larger complex compounds or species into simple forms. Write down and the electrolysis. Write down. Okay, this is a very interesting topic. So, for example, I think you have learned about the electrolysis of sodium chloride. Okay, so the sodium chloride, it has sodium ion and Cl minus ions. They are bonded by strong ionic bonds. Okay, like this. There's some lattice structure, three-dimensional lattice structure, big structure. Okay. So there are ionic bonds present in the sodium chloride. So these are very strong interactions between sodium and chlorine. So sodium is cation, chloride is the negative ion or the anion. Positive ion is known as cation. This is O level. Negative ion is known as anion. Okay. So cations and anions are there. So cations are like males. Anions are like females in general life. Alright, okay. So sodium කොල්ලා chlorine කෙල්ල එක්ක affair එකක් තියෙනවා සම්බන්ධයක්. This is a very strong love affair. So it is very hard to break. Right? So in such relationships, having these strong relationships, මේ වගේ ගොඩක් strong relationship කඩන්න සාමාන්‍යයෙන් කේලම් කියලා බෑ. හරි. කුටු ගාලා මෙන්න මෙහෙම කියලා කේලම් කියලා ඕක කඩන්න බෑ. හරිද? මොකද ඒ තරම් they are much more stronger. So it's difficult to break down. Okay? කේලම් කියලා බෑ. හරිද? ඒ නිසා ඒකට කරන්නේ දැන් අපි හිතමු උදාහරණයකට let's see කෙල්ලගේ තාත්තා ඇමති කෙනෙක්. ඇමති කොල්ල සාමාන්‍ය මධ්‍යම පවුලක it's ordinarily child male from normal family. Okay, then what the females, so the ladies or the girls father do is kidnap the kolla, kidnap the boy and then tie him into a chair. So this is a military punishment no. chair එකට tie කරනවා. tie කරලා කියනවා උඹ කෙල්ලව අතාරිනවද නැද්ද? කෙල්ලව අතාරිනවද නැද්ද? බෑ කියනවා. බෑ මම දාලා යන්නේ නැහැ. යා මගේ පණ මං ඒව දාලා යන්නේ නැහැ කියනවා. මට ක්ලෝරින් දාලා ඉන්න බෑ කියන මැරෙනවා කියනවා මම. ඊට පස්සේ මොකද කරන්නේ? Any relationship which is strong, we can break it using the current. දැන් අර මොකද කරන්නේ? අර ඉලෙක්ට්‍රෝඩ් එක වගේ අර බැටරියක් වගේ එකක් සෙට් කරලා ඒකට අරගෙන ඉලෙක්ට්‍රෝඩ්ස් දෙකක් කූරු දෙකක් ගන්නවා. රොඩ්ස් දෙකක් මෙටල් රොඩ් දෙකක් අර චිරිස් ගාලා අරගෙන පපුවට තියනවා. ඩින් ගාම ගැස්සෙන්න. Right? Okay, so මොහාට වුණත් මොන ලව්වක වුණත් කරන්ට් අල්ලලා දිවසන්න බෑ. අමාරු. It's very hard to tolerate when we are exposed to a current, we cannot tolerate that. So using the current, sodium says that like that. Okay, that way using the current we can break down the bonds in sodium chloride. So the large complex molecule is break down into simple forms. Write down. Easy example, okay, write down. In electrolysis, a direct current is passed. Direct current means DC, that means a battery. A direct current is passed. Direct current is passed through a substance to break down it into simple forms, Okay, right. So what happens here is, so there is a molten sodium chloride solution. Let's see. So there is a molten sodium chloride solution. Molten means fused, that means in a liquid state. So sodium chloride is in liquid state. So there are sodium ions and chloride ions. Now we placed electrodes there, two types of electrodes like this. So external DC current is supplied like this through a wire. Okay, in a battery, the longest rod is the positive terminal, shortest one is the negative terminal. So this electrode, due to connection to the positive terminal of the battery, this electrode gets a positive charge. Okay, then the electrode connected to the negative terminal, minus terminal, gets the negative charge. So there are two electrodes, positive electrode and the negative electrode. So we should name these two electrodes. I think you already know this. One electrode is known as the anode, other one is known as the cathode. So how do we distinguish these two? What is cathode and what is the anode? So I will tell you an easy method to clarify this. So in this solution, you see there are sodium plus ions and Cl minus ions in the molten or the fused sodium chloride solution. Okay. So what happens is, as you know, plus ions are attracted towards the negative end or the negative electrode, because we know opposite charges attracts, identical charges or the same charges repel. Okay. So these positive charge ion attracts towards the negative terminal or the negative electrode. Okay. So the positive charge ions are known as the cations. Okay, cations. So the cations moves towards, plus charge moves towards negative electrode. Okay, so the letter start with the capital C for cations, then the cations goes to cathode, capital C, Cc. Okay, so cations goes to, cations attracted to cathode. So negative terminal is cathode. This is cathode. You should know how to label this. Okay, so this is cathode. On the other hand, Cl minus anions. So they are anions, capital A, anions. Okay, capital A, anions. So they move towards, because due to negative charge, they move towards the positive terminal or the positive electrode due to the opposite charges attract towards each other. Okay, so this moves towards the positive electrode. So the positive electrode, anions attracted to anode. Anions get attracted to anode. So anions get attracted to anode. So positive terminal is the anode. You should know how to label this. This is very important. Okay, clear? This is very important. Okay, right, like this way. Okay, so what happens here is, let's see, from the external source we supply the electrical energy from external DC current. Okay, then what happens is this electrical energy inside this solution causes a chemical reaction. It causes a chemical change and converted the electrical energy into chemical energy. So in the electrolysis, the energy transformation or the energy conversion is the electrical energy converted to chemical energy. So write down below. Here electrical energy is converted to chemical energy. Here electrical energy is converted into chemical energy. Okay, this is the very important thing. So the terminal of the battery connected to the positive end, positive terminal, it gets the positive charge and it is the anode. Okay, write down. When conducting electrolysis, the electrode connected to the positive terminal of the battery, is known as anode. Write it in the red pen, anode. Positive terminal, anode. Next point, the electrode connected to negative terminal of the battery, is known as the cathode. Okay, write down the next point. When conducting electrolysis, positive ions within brackets cations, write cations, in the solution are positive ions within brackets cations in the solution are attracted towards the negative electrode cathode. towards the negative electrode cathode, negative electrode cathode, negative electrode cathode, and negative ions, negative ions, negative ions within brackets anions, anions in the solution, in the solution are attracted towards, anions in the solution are attracted towards, positive electrode anode, attracted towards positive electrode anode. Hari, it's easy no, cations yanne cathode එක පැත්තට, anions yanne ඇදිලා යන්නේ attract වෙන්නේ anode එක පැත්තට. Okay, that's simple. Okay, you can write this one, but before that write down as an example, write down below, write down example, electrolysis of molten NaCl, electrolysis of molten NaCl, molten means fused or the liquid state, electrolysis of molten NaCl or fused sodium chloride. Hari, under that one, so write down this one first, so it's very clear. So there are sodium plus cation attracted towards, they are moves towards the negative electrode, therefore the cations moves to cathode. Highlight the first two letters of cations, CC, C, cations goes for cathode. So cations, as the cations are positive charge, they goes to the negative terminal. Okay, negative N, write this. Then Cl minus, that is the anion, anions, they moves towards the positive because they are negatively charged, they are attracted towards the positive electrode. So the anions attract to the positive electrode, AA, anions goes to anode, anion goes to anode. Okay, it's clear, no? Right. Now, then draw this apparatus, draw the electrolysis apparatus, draw this one, draw it neatly. If you need, you can use colors, for the one color for the cation, another color for anion. It is very clear there. Draw the apparatus. So in 2020 A level paper, MCQ number 17 as I can remember. So it was given this electrolysis apparatus setup, and you are able to identify the anode and the cathode. Okay, so it is very important. Okay. Okay. As you have studied, actually what happens here? So, sodium ions attracted towards the cathode, and what happens there? Let's see, there is a reaction, okay. So, at cathode what happens is, at cathode, sodium plus ion which is in the liquid state accept an electron from the cathode and become sodium solid. So, the element sodium is removed at the cathode from the cation, okay. So, then at anode what happens is, Cl minus in the liquid state anion, molten chloride ions, becomes chlorine gas and evolved from anode, okay, near to the anode. Right, these are the two reactions that occurs at the cathode and the anode. These are simple, they are in your always also, right. Write down, in electrolysis of molten NaCl, in electrolysis of molten NaCl, in electrolysis of molten NaCl, sodium metal is Na metal, sodium metal, Na metal is liberated at cathode, sodium metal is liberated at cathode, and Cl2 gas is liberated near the anode, and Cl2 gas is liberated near the anode, near the anode. Hurry, clear? Okay. So, from this we can see that when the molten sodium chloride is broken down, so we can break down this into simple forms of sodium metal and the chlorine gas. The complex ionic lattice in sodium chloride lattice structure is broken down into simple forms like sodium metal and chlorine gas. So, this is due to the electrical nature of matter. For example, in sodium chloride there is a electrical nature. So, when I am taking the simple example, සරලව කිව්වොත් එහෙම දැන් ඔයා නිකන් හිතන්න දැන් බාහිර කෙනෙක් ඉන්නවා, external source එකක් තියෙනවා. There's an external source. Let's see that as a person. So, you are there. So, if you have a nature of getting angry, ඔයාට තරහ යන ස්වභාවයක් තියෙනවා නම්, nature එකක් තියෙනවා නම්, if you have a nature of getting angry, if external source do supply something, external source supply an energy which will arise your වැඩි කරනවා නම් ඔයාගේ anger එක, what happens? You get angry. So if I ask why you get angry, because you have the nature inside your mind to get anger, to get angry, okay. So as you have the nature to get angry, when an external source that supports your anger comes from there, you get angry. So likewise, because sodium chloride matter has the electrical nature, we can supply the electricity and causes a change in sodium chloride. There sodium chloride කියන්නේ matter එකක් නේ. එයාගේ change එකක් කරන්න පුළුවන්, reaction එකක් කරන්න පුළුවන් නම් external electricity එකක් දීලා එයා ඇතුලේ electric nature එක තියෙන්න ඕන. නැත්නම් electric nature එක නැත්නම් අපිට කොච්චර බාහිරින් electricity එකක් දුන්නත් we cannot make any change in sodium chloride. So that's why. So this shows that electric nature of sodium chloride. Write down. Molten NaCl solution, molten NaCl solution can be separated to molten NaCl solution can be separated to Na sodium and Cl2 chlorine Cl2 due to electrical nature of matter. Due to electrical nature of matter. Due to electrical nature of matter. So, this is the second evidence to support the electrical nature of matter. There is one more thing. Okay, so in your first day of your lecture series, this one session. So, first of all, as I said, you have to watch the initial video of single medium, because that is the video that gives you the introduction. Okay, introduction about the A-level life and other things that you should know before you start your A-level journey. Okay, so you should watch that one in this week. Also, after this video, after this class, you have to watch it, or if you don't watch it, you can watch it later. So, if you watched it already, that's okay. Okay. So, in this session, I will wind up this session after teaching you the last evidence of this electrical nature. So, for the today lessons, I will wind up my lesson after teaching this part. Okay. So, write down the number 3. Number 3, the third one, it is the opposite of electrolysis. You know what is that? Electrochemical cells. Opposite of electrolysis. Electrochemical cells, or it is known as simple cells. Simple cells. Simple cells. Electrochemical cells or the simple cells. Write down the third evidence. Electrochemical cells or the simple cells. So, it is the opposite of electrolysis. Okay. So, what happens here? In electrolysis, we supply an external electrical source, electrical current, and we causes a chemical change. Now, in a simple cell or electrochemical cell, we brought up a chemical reaction and it generate electricity. Okay. So, the chemical reaction involved in a cell, simple cell, generates electricity, and we take that electricity as an output to use it in our day to day life. Okay. Write down. Cells that produce an electric current, cells that produce an electric current, cells that produce an electric current, cells that produce an electric current from a chemical reaction, between substances, are known as simple cells. Let us get a simple example for simple cell. Okay, you have a beaker like this, and you have here dilute sulfuric acid. It's a dilute sulfuric. You can immerse 2 electrodes here. Let's see, one is a zinc electrode, other one is a copper electrode, zinc and copper. Okay, the one electrode is zinc electrode, other electrode is, one is zinc electrode, other one is the copper electrode. Then you connect this one into a bulb. Connect it to a bulb. What happens here is, when there is a chemical reaction occurs inside this beaker in the solution, that will generate electricity, and this will light up the bulb. Like that way. Okay, write down example. Write example. When a zinc electrode and a copper electrode zinc electrode and a copper electrode are immersed are immersed partially immersed partially සම්පූර්ණයෙන් මේක බග් ගාලා ගිල්ලන්නේ නැහැ මේක ඇතුලේ. It's partially immersed because part of the electrode is inside the solution, other part is exposed to the air. Okay, partially immersed partially in a dilute H2SO4 solution. In a dilute H2SO4 solution, dilute H2SO4 solution, they react with each other. They react with each other to produce. They react with each other to produce electricity. To produce electricity that can glow a bulb. That can glow a bulb. That can glow a bulb on external circuit. That can glow a bulb on external circuit. So draw the apparatus. Now draw this. Now draw the apparatus. So this is a simple cell or electrochemical cell. අපේ ගෙවල් වල තියෙන බැටරිය it's much more complicated than this, but it's also electrochemical cell. We use batteries in whatever, in clocks, in our TV remotes and whatever. Okay, we use in torch, we use simple cells or the electrochemical cells, and we produce electricity from that. Okay, so the setup of normal pentorch battery is different from this one. Okay, you will learn it in electrochemistry lesson. Okay, this is the example for the simplest cell. This is also called the galvanic cell also. Maybe you have learned that word, galvanic cell. So any cell that converts chemical energy into an electrical energy is a galvanic cell. So for example, this is a one type of galvanic cell is the simple cell. Okay, in other words, electrochemical cells. Draw this. So what happens in here, the chemical energy is transformed into electrical energy. Okay, write down. In here chemical energy is converted into electrical energy. In here chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy. Clear? Okay, in here also we can see that this evidence also shows that there is electrical nature in matter. Why? These materials, dilute sulfuric substances, copper and zinc, they react all together to produce electricity. Same example I told you earlier, අපේ ගාව තරහ යන ස්වභාවයක් තිබ්බොත් තමයි අපි අපෙන් එළියට තරහ යන්නේ, like that. Okay, අපේ තියෙන තරහ outside එකට යන්නේ, it's the same phenomena. Okay, so we have the anger, so for reaction we get angry and we show it to the external person, to an external source, anyone. Okay, so it is because we have the matter of anger, or we have the nature of to get angry. So we have the nature to get angry. So the material substances have the nature or the nature of electricity, electrical nature. So when they react, they given out electricity. So this is the evidence. This is also an evidence to show that electrical nature of matter. Write down. Okay. Zinc Zn, copper and dilute H2SO4. Reacts together to produce electricity. This is because these matter has an electrical nature. This is because these matter have an electrical nature. These matter have an electrical nature. Okay. From all these three evidences, okay, we can show that the matter has some electrical nature. Right. Now, from above experiment, the scientists analyzed that atoms should, in order to show electrical properties by matter, okay, as the matter is made up of atoms, so the matter shows electrical property. Try to understand this. Matter has the electrical property. This shows electrical property. For the matter to show electrical property, matter is made up of atoms. ඒ කියන්නේ මේක එළියට දෙන්නම් ඇතුලේ තියෙන උන්ටත් ඒ ලක්ෂණේ මේක තියෙන්න ඕනේ. It should be. Okay. So as the matter has electrical nature, atoms that make the matter also should possess electrical nature. හරි. Also should possess electrical nature. Matter එක electrical nature එකක් auto පෙන්නන්නේ නැහැ. They cannot show it spontaneously. No. So it is because the atoms that make the matter should contain that nature, electric nature. So the atoms have the electrical nature. Due to the electrical nature of atoms, the matter shows the electrical property. So that was the inference. Okay. So that was the conclusion that they got. Okay. So then they thought that to show the electrical nature, there should be a electrically charged particle inside atom. Electrically charged particle should be present inside atoms. So due to this electrically charged particle inside the atom, atoms get the electrical nature. So due to the atoms get the electrical nature, matter also get the electrical nature. That was the conclusion. Okay. So this electrically charged particle was named by a scientist known as Stoney. This was the name of the scientist. Scientist Stoney named this particle as electron. So this is the naming of the charged particle, electrical charged particle inside the atom by Stoney as the electron. Write down. From above experiments, scientists analyze that atoms in matter should contain an electrically charged particle responsible for their electrical nature. Write in red pen the name of the scientist, Stoney, within inverted commas, Stoney termed this charged particle as what? Electrons. Write in red pen, electrons. So who named the word electron. Who introduced the word electron to the world? Stoney. He was the person, scientist, who introduced the word electron for the charged particle inside the atom. Okay, electron. So this is the end of the first day of your English medium class. So my dear students, if you have any friends you know, you can add all them into the WhatsApp group, as you know our WhatsApp group, so we can continue our journey together. So please tell your friends about this, and you can share this video, no problem, you can share this, share to all your friends who are doing English medium. So I think you have understand what I taught here. Okay, taught here. So if you have any doubt, you can WhatsApp me anytime, so I will answer to your questions and I will clarify them. Okay, this is the end of the first session, so let's see in the next session. Okay, bye.